Hey everybody, this is Mr. Charnetsky, and this is Unit 2.3, Lesson 3, Dilations. Okay, so we are going to only focus on dilations that have a center at the origin. And what a dilation means, we have our previous transformations of translation, reflection, and rotation. Those are all known as rigid transformations. A dilation is a non-rigid transformation, meaning that it changes size, but it does not change shape. So basically, it takes a shape and makes it smaller or larger. If it makes it smaller, we call that a reduction, and if it makes it larger, we call that an enlargement. So the key to this determining what happens is knowing what our scale factor is, which is denoted by K. And this tells us two things. It tells us whether it's a reduction or an enlargement. So if K is less than 1, it's a reduction, meaning it's getting smaller and it's shrinking towards the center of dilation. If K is greater than 1, then it's an enlargement. Okay. The other thing that K gives us a scale factor is if we are dilating from the and our center of dilation is origin, our new coordinates are going to be given by multiplying our old coordinates by that scale factor. So for example, in number 1 here, we have triangle ABC is dilated by a scale factor of 2. So let's write down the original coordinates. So A is at 3, 7. B is at 3, 4. And C is at 8, 4. Now our scale factor equals 2. So we're going to multiply each of these coordinates by 2 to get our new coordinates. So A prime is going to be at 6, 14. B prime is going to be at 6, 8. And C prime is going to be at 16, 8. So essentially I just multiply these all by 2, which is our scale factor. Okay, so when I do that, I get 614. There's A prime. B prime is 6, 8. And C prime is at 16, 8. And when I connect those, we get our enlarged triangle. All right, number 2, we have this is basically parallelogram S to UV, and it's got a scale factor, or we're going to dilate with a scale factor of 1/2. So this is a reduction. So we're getting smaller. Let's start again. Let's write down our original coordinates. So S is at 8, 14. T is at 6, 10. U is at 12, 10. V is at 14, 14. All right, now we're going to multiply by 1/2 And multiplying by 1/2 is the same as dividing by 2. So you're taking half of these coordinates. So our new coordinate for S is going to be 4, 7. T prime is going to be 3, 5. U prime is going to be 6, 5. And V prime is going to be 7, 7. So let's go ahead and plot those. So V prime is right there. U prime 6, 5. T prime's at 3, 5. And S prime's at 4, 7. And we'll connect the dots. And there is our dilated parallelogram. So that's the key to dilating if our center of dilation is at the origin, which it is for all of these problems. Okay. All right, that's the end of this lesson.